technology education. I have been using technology well, essentially my whole life. I begun using computers back in the 60s, and I sort of grew up with them. But I was in that sort of the elite of the people who had hands on these big computers where the average person only heard about them on radio and television. So the idea was, here's this new technology that's coming of age. What's the potential for using it in education? I mean, up to this point, people had to get advanced degrees in computer science before you go in and program a computer. It wasn't obvious that school kids were going to be able to use these systems beneficially. So I look back on other new technologies. Now, the new technology that appeared when I was a child was television. I grew up in the 50s, and television was the new technology of the era. And it was used for lots of things, but one of the things it was used for was it was used for education. And I remember some of the more successful educational TV programs that were on when I grew up. There were puppet shows like Howdy Doody that had kids in the peanut gallery and little edutainment activities with participation. There were, let's see if I can remember some. There was Mr. Wizard, one of my favorite. Don Herbert spent his whole life doing science for kids on television. So those were some of the first generation uses of television. Now, it's an interesting thing about Howdy Doody. There was a character on Howdy Doody who never spoke. Wore a clown costume, had a little bullhorn, Clarabelle. Now, when Howdy Doody went off the air, Clarabelle the clown took off the costume and became who? Anybody know? Captain Kangaroo. Yeah, Bob Keeshan. Believe it or not, he was Clarabelle the clown, and he essentially invented the second generation of children's educational television. He basically created Captain Kangaroo. And about in that same time frame, Fred Rogers, Mr. Rogers' Neighborhood came out. And the third generation, there was one other first generation I didn't mention. Another puppet show, was a terrific puppet show. Kukla, Fred and Ollie, with Bert Tillstrom and Fred Allison and a couple of little hand puppets. Puppets keep coming back a lot in children's education. The third generation of children's educational television was Children's Television Workshop, Sesame Street. And they had a terrific puppeteer on that one. He's now passed away. You know who that was? That was Jim Henson. Now, Jim Henson was about my age. And when I was a youngster watching television, and I kind of fell in love with Mr. Wizard, he fell in love with Bert Tillstrom. And he grew up to basically be the second generation of Bert Tillstrom. And I always sort of wanted to be the next generation of Don Herbert. So the character that I portray in MicroMuse is sort of the science guy. But so that was sort of in the back of my mind, the back of my personal history was this awareness of sort of three generations of innovation in children's educational television. So here's the internet now. The internet is now about 30 years old, but back around 1990 it was about 20 years old, but really it had just coming out of the research and into general use. And so I thought, we have to do for the internet what those pioneers did back in the 50s and 60s and 70s for television. We have to find innovative ways to take this medium and make it accessible to children in a fun, entertaining, but educational way. And that was the challenge, because after all, this technology was not designed for kids. But we thought, well, maybe we could do it. So I was looking around for ideas. I was on the news groups, which were sort of the only community that existed was the Usenet news groups in those days. Looking around for ideas, and I came across a phenomenon that began in the late 80s. And this phenomenon actually goes back earlier than that. One of the things that made computers fun was games. And even back in the days of mainframe computers and mini computers, there were games. programmers love to make games. And of all the games that I found on the computers back in the 70s, the ones that I thought were the greatest were the text adventure games. These were developed by people who were in artificial intelligence, computer science, and they were really pushing what things could do. And one of the oldest adventure games was called Adventure. It was developed by a couple of computer scientists. One was at Stanford, Don Woods, I think. I forget the other one. But when was it? Crowder. Oh yeah, Crowder. Who was at BBN? Crowder Woods. So when personal computers started coming out in the 80s, there was a company that was spun off of MIT to develop these text adventure games. A company called Infocom. And they built a series of games called Zork, some of you may have heard of. And they adopted this sort of text adventure. You go into this imaginary world that's all described in text, and you have to sort of wend your way through this world and find all the stuff, and so on and so forth, and solve the puzzles. And they were really terrific games, very imaginative. Well, in the late 80s, that technology evolved from single-player adventure games, one on the computer, to network games where multiple people could log into a common database. And that technology grew out of a research project at Carnegie Mellon. When David was a grad student, he was doing some work in artificial intelligence and natural language work. And there was a fellow at Carnegie Mellon doing similar work in natural language, artificial intelligence. He went by the name of Dr. Fuzzy. His real name was Michael Malden. And he wanted to do an experiment where he built one of these robots. In fact, it was the precursor of Caspian. Those of you who saw Caspian, it was the precursor of Caspian. He had written this little character who could have conversations with people in text. And he needed to have subjects come in and converse with him. So he had a friend of his write this little computer world where you could log in over a terminal and converse with Julia, who was the name of the female robot character. And then he got his undergraduates to come in and have these conversations with Julia. Well, the kids who came in to do this experiment, they thought it was fun to talk to Julia, but they also thought it was just fun to be in the system. And because it was done over a teletype system, they could talk to each other as well. And out of this system grew the first Tiny Mud back in the late 80s. And the fellow who developed it put it up on the internet somewhere around 87, 88. And it became a phenomenon. It was the buzz. And so if you're reading news groups, and what's going on, you hear about these MUDs. So I was reading news groups, I heard about the MUDs that started from this experiment at Carnegie Mellon. So finally, I logged on to one to see what it was about. And the first thing it said was, you have to register, pick a name, self-registration. So this is the first time I was ever asked to make up a name. So I'm staring out the window, I'm sitting in my office at BP, and I have to come up with a name. So I look out the window, and my eyes landed on the street sign at the corner of Concord Avenue and Moulton Street. So I know I didn't want to be known as Concord Avenue. Actually, that's how Moulton was born. Anyway, I was taken by these MUDs. I thought they were really interesting, they were easy to learn, powerful, and I thought, this is a neat idea. I wonder if we can use this for education. So the first thing I did was, to test that out, I created my character of Moulton, and one of the things that I did when I moved to Boston area back in the late 80s is I started doing volunteer work at the Science Museum. And I was working in a room called the Children's Discovery Center, just a little Montessori room with lots of fun stuff to play with. And so we had all these, toys and things, gadgets to play with. And so I recreated my Science Museum weekend volunteer character. Moulton was essentially a copy of what I was doing in the Science Museum. And I would wander around these MUDs with this little bag of, little program gadgets that that represented things that I had in real life in the Science Museum. A little ball, you touch it, it would light up, and fun little things like that. So I'm wandering around as itinerant scientist, encountering people, they're mostly college students, and entertaining them with these little lightly programmed science gadgets. And there I met a senior in college who was a computer science student in California who was rather charmed by this character Molten and this little itinerant bag of science tricks. And he said, I'm going to start another mud like this one, but it's going to be different, and I'd like to have you come and join. So, and his name was Stan Lim. He's known as online as Jin, J-I-N, and he's the founder of MicroMuse. He started a little mud called MicroMush on a little Sun 3 workstation at Cal State University in Fresno, and I was one of the very first people to come join him, and that was the beginning of what became MicroMuse. And he decided to do a kind of a futuristic world, 24th century world. And one of the things that people started to do is they started to build a solar system. But it was an imaginary solar system. One of the first things that was built was Ender's Moon. Ender was another student that Jin had recruited. And was building this sort of imaginary moon. And I said, you know, if we're going to build stuff, like moons and things, why don't we build an accurate model of the real solar system? Why don't we do accurate science, not just fantasy science? And the idea caught on. And as it happened, one of the people that showed up was an astrophysics student from Utah State University. And he actually ended up building much of the code that simulates the Newtonian gravitational mechanics. Now, if you go out in MicroMuse and you go into a spaceship and visit the planets, they all, in fact, orbit the sun, and there's real gravity and F equals ma, real Newtonian mechanics. And it was one of these grad students in astrophysics who put all that in. So we ended up building MicroMuse as chartered as an educational mud, non-violent. Some of the muds were social, and some of them were kind of Dungeons and Dragons, slay the monsters and have combat, kind of like Tolkien and stuff. Okay. And we thought, well, there's tons of places that are like, Tolkien, Dungeons and Dragons, and there's plenty of ones that serve the purpose of social, recreational needs of college students. We wanted to build one that was educational and scientific and nonviolent. And that was sort of the one thing that I said, I think that'd be fun. If you want me to participate in this thing, it has to be a nonviolent world. I don't want a world where you go around killing each other. There's enough of that. You can get that anywhere. Let's have a nonviolent world that's fun, educational, and social, recreational. That's fine. But what's some real, some real learning by this? So that we chartered ourselves as an educational, nonviolent educational mud with interest in science. Now, about this time, we started to get, we opened the public, we started getting a number of young people on, including a few high school kids. We didn't have a whole lot of high school kids on, but we had a few on. And the high school kids that we had on were on because their parents were in academia. So that's how they got access. So about this time, there were some graduate students at MIT who were working with us at BBN in the Educational Technology Research Group, and they'd come over about once a week or once every couple of weeks to share with us the research. And every once in a while, they would drag one of the professors over with us. So, so one day, Mitch Resnick and Mike Eisenberg come over, and they bring Hal Abelson, professor from MIT, with them. And I kind of knew who Hal was because he was pretty famous for artificial intelligence back then. Well, he comes over with his two grad students for lunch to chat about what they're doing. So we go up to lunch, and we sit at a big round table. And I sit down next to Hal because I want to get to know him. And Hal says, I only have one daughter. She goes to West Newton High, And she's never been interested in computers, which is a great disappointment. He said, but my daughter and her friends, two of her friends, have found this really interesting thing on the internet. And they've been going to this thing, that's all we ever talked about, and he's describing with his daughter. And I said, Hal, are you talking about MicroMush? He says, yeah, you heard of it? I said, Hal, I'm molten on Micromush. He says, you're molten? I've heard all about you. So right away, we had this connection that was kind of astonishing. Well, not too long after that, Jen, the graduate student or the computer science student at Cal State who had started MicroMush, he says, I'm a graduating senior. It's now spring. He says, I'm going to graduate in May, and we'll lose access to this computer here at Cal State. We're going to go off the air. I don't want to go off the air. I said, well, let's think about that. He says, in the meantime, he says, spring break is coming up. I'd like to come to Boston and meet you. So I said, sure. So he comes to Boston over spring break, and one of the things we do is we go down to MIT because he wants to meet I've forgotten Hal's daughter's characters. Her real name was Amanda. That was not her name. I went down to meet Amanda and Hal. So we had to say our hellos, and then we get around to the real issue, which is that we're going to go off the air. And so I asked Hal, any chance you might have some spare computing resources that we could keep this thing going? And Hal, without batting an eye, says, oh yeah. He says, we have a machine, out in the hall that's donated by Motorola, and I'm not using it. You can have it. So we ported MicroMush to this computer at MIT over the next week, and about the same time we changed the code and the name. We changed it to MicroMuse. The name we used stands for Multi-User Simulation Environment, and it was suggested by one of my colleagues at BBN, the same guy who also named the logo Computer Language for Children. So we end up with a new home at MIT, and Hal's daughter went on to run her own Muse in addition to MicroMuse, and he ended up using it in his course 6001, which is the structure and interpretation of computer programs. They used Muse as a vehicle to teach all kinds of neat stuff in computer science. And a few years later, Hal Abelson and his daughter Amanda wrote a book, not about Muse, happened to be about Logo. But they co-authored a book, and on the back of the book, you see a picture of Hal Abelson and Van Abelson kind of standing back to back, it's a cute pose. And this is Hal Abelson, professor of artificial intelligence, and Van Abelson, who runs a MUD on the internet. So, what it did is it took his daughter, who essentially had shown no interest in computers, and drew her into this fun world of computer programming, and created an opportunity for father and daughter to work together at a very interesting level. It kind of leveled the playing field. So that was one of the first really interesting stories of the educational value of a system like the MUD. And because of the importance of a person like Hal Abelson, it really kind of made it clear to other people who were interested in technology education that it would be something powerful here. There's some other really great stories. One of the youngest, a couple of the youngest kids on, we had a 7-year-old boy who lived here in Arlington. Come on, Chris. It was a 7-year-old boy who was one of the smartest kids I've ever met. He was homeschooled. And he used to come around for enrichment to our group at BBN. So I introduced him to MicroMuse. And at the age of 7 or 8, he built the Wizard of Oz version, which is still there. You can see it. His name is Reed. That was back in the early 90s. Now, Reed is now about 17 years old. And I recently put his name into a search engine to see what he's up to. And it turned out that last year he was very bright in mathematics. He had entered the International Math Olympiad. This was an international competition for mathematics. And he was one of 4 students worldwide who got a perfect score. But what was even more astonishing was that the chairman of the International Math Olympiad was my old calculus professor from the University of Nebraska. So it was a really neat connection. And I got to catch up with my old math prof from 20, 30 years ago too. So he was one of our star students. Another one was the son of a network guru. There was a guy out in Boulder, Colorado, who was also trying to do educational networking. He had a couple of children that he gave access to. One was Calvin. And one summer, since they lived out in Colorado, they went to Yellowstone for the summer vacation. So he comes back, he's all excited about Yellowstone. And you know, when you come back from your summer vacation, you know, right, what I did on my summer vacation, well, what he did is he built Yellowstone. He built a model of Yellowstone in MicroMuse based on his experience at summer vacation. Now, the neat thing about it was he was actually a pretty good programmer. He programmed the moose and the geyser and all that kind of stuff. But he was kind of light on the prose. So when you go to describe the scene, the prose was kind of thin, and also the spelling was atrocious. So he builds all this stuff, but it's not a lot of description, not a lot of narrative with it. And he wanted to open it to the public, and he said, well, you have to kind of fix up your prose, and especially if you fix up your spelling. And he bitched and he moaned and he dragged his feet, and time would go by. Finally, after a few months, he hunkered down and fixed it up. Fixed all the spelling, and he opened it. Great fan, it was a big success. A few months later, his father happened to come to Boston on business to talk to some colleagues, and so he brought Calvin, and I think the younger sister along too. So they were visiting some people in Boston. So David and I went over to have a Sunday afternoon barbecue and meet Calvin and his sister and his father. So we're visiting. We're walking. We live over in Beverly. We're walking along the beach in Beverly in the afternoon, and I finally get a chance to talk to the boy's father. And I said, his real name was Nathan. I said, what did Nathan learn on my? His father said, that's very interesting. His worst subject in school was spelling. And he was terrible. So something happened on MicroMuse, and he hunkered down, he learned his spelling, and then he entered the Colorado State Spelling Bee and won. Well, we would get story after story of, the relationship, what would happen. Kids would come to MicroMuse, and they would kind of get, fired up, and they would have some breakthrough learning. And so there's lots of stories. You can read about a lot of these stories online. But what we found was that it was a successful technology. It was cheap, zero cost. The computers we ran on was essentially free, junk computers. The software was in the public domain. It was being developed by college students and eventually high school students who were writing the server code. The content of the world was built by the participants. And so the kids would build something and have instant show and tell. And they want to show it to their buddies. So one of the more successful projects was there was a school in Worcester. And what happened there was the teacher happened to come to the Science Museum one day. And he walked into the Discovery Center where I was a volunteer. I just had a conversation with him. I didn't know he was a teacher. But I had a long conversation with him, during which time I mentioned MicroMuse at one point. And he said, gee, I want to take a look at it. So he did. And after a while, he decided to try it out with the students. So he organized 3 classrooms, and this was like 3rd to 6th grade, in a blue-collar section of Worcester where the kids are, not exactly underprivileged, but they're not cream of the crop exactly. And they put them on MicroMuse, and they worked it in the curriculum. So, for example, one year they were doing American history, and they grouped the kids into groups of 3 or 4 kids in a group, and each group was given a scene from American history. For example, the Paul Revere scene or the Ben Franklin scene, some classic scene. And the kids programmed a little version of this scene, the characters and the text, so that you go into this little scene and you have this little live scene. So they were learning the American history. They were learning the Muse, the technology of the Muse code, and they were also learning language arts because there was, And so they would build all this stuff, and then they would, want to show it to the other groups. So there was this instant show and tell. That would turn out to be a very successful project, and they used that for a couple of years with different subjects besides American history. They did one on Java too, and had terrific results. We got a glowing letter from the principal saying that these kids who were sort of muddling along, suddenly their language skills just shot up. Their vocabulary, their grammar, their punctuation. That's really hard to get kids to do reading and writing in grammar school. These kids were doing reading and writing, and their skills just shot up amazingly. Teachers couldn't help. So we had similar results with a school down. Yeah.
Just wondering, what happened to that programming? Was there? Are they still doing it?
No, they're not doing it anymore. That's they didn't have. Turns out at the time that they did this, they didn't have one computer in the classroom. So I took old VT terminals, junk terminals. I put them in the back of my car, and I carried them out to Worcester, and I set up on tables with the terminal server a whole bunch of old terminals. And they used those old terminals for about 3 years until the school they were in was torn down, and they built a new school. And the process of tearing down the old school and the new school, kind of all that stuff kind of went away. So, and one of the teachers who was in that project left the school and joined BBN to work on another project in education. He got interested in educational technology in the lodge and ended up becoming a field rep for an educational technology project at BBN. I don't remember what happened to the other two teachers, but the project ran for about 3 years there before we kind of ran out of steam. And then they ended up doing this other project that was called Connect for a while at that same school. And I think the Connect project is still running, but I don't know if that particular school is using it anymore. There was one other project down in Phoenix, Arizona, where there were a couple of professors from the community college. There's a huge community college in Maricopa County, which covers Phoenix. The problem was that the students who were coming out of high school were kind of falling farther and farther behind, and the community colleges were worried about preparedness. So they thought we need to do something to get students better prepared so that as they come through the public school system, they're prepared for community college. So these two professors found out about MicroMuse, and they came and logged on, and they were interested in this constructivist theory of education, which is what we were doing. And they thought, we think this could work. So they proposed to a local elementary school to try it out there. And they borrowed, David, they borrowed a couple of our technical people, and they built a copy of MicroMuse. It was called MaryMuse. It was called MaryMuse, and it used our server. And it was especially just for their students. Now, these were students who were really from the inner city, Black, Hispanic, Native American, broken homes, drug infested. This is sort of, where you're lucky to get the kids to show up in all the school. And they started off with a summer camp. They did a MaryMuse summer camp, and they brought these kids in, and the kids were glued to the system. They didn't even want to take a break. The summer camp was a big success. They decided to try it in the regular classroom or in the regular school year, and it was a phenomenal success. And you can read about MaryMuse, which eventually became a Pueblo project. They switched from our server to a different server, a new server eventually. Got funding from the federal government, worked with Xerox PART, and built a system called Pueblo. And that was at the Longwood School, and they had just astonishing results with these kids. And the same kind of stories that I told about Micro's, they have even better stories to tell. So that's sort of the origin of that. Now, meantime, my role in all this is I'm husbanding the local machines here, and I'm thinking about technology and education, but at the same time, we're doing community building, because the people in MicroMuse are community. Now, I know lots about communication technology, because I come from Bell Labs. I've done network planning, I knew all about telephones and all that, computers, but I didn't know a whole lot about community building. That's a very, it's leadership and social stuff, and that was kind of new territory for me. So I was trying to understand how you get all this stuff to work. Now, one thing that we needed is we wanted a community where people got along, where they collaborated. So one of the things that we introduced was a social contract. Now, the social contract is instead of having rules enforced by some kind of a police force, we instead had a social contract, which is an agreement among the participants. The participants actually wrote their own social contract. And it was how we're going to treat each other, how we're going to get along. So we had a kind of government system that was rather advanced, considering how most communities are governed by some governing authority imposes the rules, and there's some enforcement mechanism if you violate the rules. We didn't want to do it that way. So we did the social contract method. And this led into some interesting results on community building, which generated a model. I do models, systems thinking models. And the model that came out of this was interesting. Remember, we began with communication technology. We had computers, software, and the internet. That allowed people to communicate over distance and form a community. Okay. So this was the bedrock. This is the soil. Communication technology, without which none of this could have ever happened. And that came of age in the later part of the 20th century. So then, on top of that, we're doing community building. So the communication technology is making it possible to do the community building. Now, community building, the social contract was a big thing, but the other thing that was important was to build trust. The hardest thing to build in a community is trust. You want to give people freedom, but you don't give them freedom unless you trust them not to abuse it. So if people use their freedom responsibly, in compliance with the social contract, and you give them a lot of freedom, and people can collaborate, and lots of good things can happen. And in fact, that's what did happen, and what came out of this is something that I did not anticipate, which astonished me. And I had to give it a name, so I called it communion. And it only happens if you get high levels of trust. And what I mean by communion in this context is transformational relationships of people to people and people to ideas. I'll say that again. Transformational relationships of people to people and people to ideas. And that emerged when the community gelled because the levels of trust got high enough, and it worked because we had a social contract that people voluntarily subscribed to. So this model, this three-layer model, I call by the common, take the Latin root, Communitas. That's the name of this model. It's a three-layer model. And I have to tell you, it was the first time in my life that I ever got to this stage in any community I was in. Other people have probably gotten to this in other communities, but in my experience, never in my professional career did I ever get to this level in an organization except in mud rules. So that shows you the possibilities that you can get. Transformational relationships, people to people, people to ideas, when the trust levels are high, when you do the job of community building, and the MUDs made it possible to do that.
How long did it take to get to that? Probably different for everybody involved, but for you personally, how long did it take before you felt you had that?
I think we got here around the mid-90s. we went through some times when we had to rethink the social contract, rewrite it, and get it right. But we eventually got there somewhere in the mid-90s. This was hard work. This was the easy part. We all knew how to write software and, you know, turn on a computer. We could code up the objects in the database. That was the problem. The problem was building community. That was the hard stuff, because none of us were really trained in, you know, the leadership skills. We had to sort of develop this, you know, on the fly.
The mid-90s would be about 3 or 4 years. But I'm not sure if it really, I mean, I think it sort of built itself up, and then there were problems, and then it had to rebuild itself. So I think some of that did develop within the first year, but then had to be redeveloped over time as the community grew.
How big was the community, and what percentage do you think experienced it as actual Communitas experienced at higher levels than you talked
Over a period of a decade, we've probably had a few thousand people come through the system. At any one time, maybe we've had as many as a few hundred active people who would log in regularly, and maybe the core of really highly invested people would be of the order of maybe 50 who were really heavily invested and had high levels of ownership.
This is years ago. This
Yeah.
point,
Yeah.
the numbers are nothing like that.
We're down now. I mean, last Monday we had 32 people on when both these classes logged in. That's the most I've seen logged on at one time in quite a while. Normally we don't have more than 30 people logged on. The MUDs basically had their heyday in the mid-90s. When the web came out, the HTML and the web came out starting around 93. It didn't really catch on for a couple of years, and then the internet went commercial. And when the internet went commercial and the web technology came out, that kind of was the thing that swept most people away from other activities like the text-based MUDs. So the MUDs are still there, but they were the buzz in the late 80s, early 90s, and sort of reached their peak probably in the mid-90s before the web kind of took over. Let's see, other time, a few more minutes, maybe just say a few more random. Oh, I should tell a story about David. This is not embarrassing. This is not an embarrassing story. I mean, I said that I was a volunteer in the Science Museum. Well, so was David. David was an exhibits interpreter. David grew up here and had been familiar with the Science Museum, essentially his whole life. I moved here in the late 80s and became a volunteer in the Discovery Center in the late 80s. And so we're not in the same section, but I would see him wandering around as the exhibit and his badge on here. He'd wander into the Discovery Center every once in a while to visit, so I got to know him a little bit. And one day he wandered in, and he was in the middle of his graduate work, and kind of feeling, overloaded, looking for something fresh. And I happened to tell him about MicroMuse, and he lit up. He just lit up. Spent about 10 minutes sort of giving, a condensed version of what I explained to you, and he says, I saw him go in there and be Aslan the Lion and build an art. And he did. He came in and in an astonishing record time built still, I think, the most phenomenal adventure that you can find on MicroMuse, which is the Narnia adventure. Narnia. The C.S. Lewis children's classic. You all know about Harry Potter, right? You know about Tolkien? Okay, the other one in that genre is C.S. Lewis Chronicles of Narnia. And that was written mainly for children, maybe 8 to 11, sort of nominally. Anyway, David's a big fan of the Narnia story. So he came in, adopted the character Aslan, which is the character of Narnia, and built a beautiful Narnia adventure, which was interesting in a very important way. Most of the adventures that people were building were single player adventures. You go into it essentially by yourself. He wrote an adventure where it took a party of 4 working as a team cooperatively to solve the first puzzle. And that's not easy. It's hard enough to write an adventure and reviews that works for one, but he wrote one that required people to cooperate. So again, it was promoting cooperation and collaboration. So those of you who have some time to spend in MicroMuse, go see Narnia. Also go see Oz, which was done by a 7-year-old, 8-year-old boy. You can do this one in probably about half an hour. The hardest part in Oz is getting in the gate of Emerald City. When the doorman challenges you at the gate, you have to say exactly what the doorman expects or he won't let you in. And everything else is pretty easy in Oz. Narnia is much richer, more complicated. There's lots of other adventures that you can go visit. David came into Narnia, and then he also built Caspian, the robot, which is descended from that robot, Julia, that was how the month got started back in Carnegie Mellon, back in the 80s. This was our time here. I don't know if I want to talk about theory or maybe it's a good time to stop and ask if people have questions. What others have questions? So let me pause here and see if people have comments or questions. Yes.
Have any teacher materials been developed? I know that there are materials on, how to get into the Muse and use the Muse, but sometimes with popular books or movies in the culture, you'll see teacher materials or teaching guides that will show how to incorporate something into the curriculum. Has anything like that been developed? And also, I know the Museum of Science has a program of science teaching materials that groups of students, as few as 4, can subscribe to. Have you thought about piggybacking on that as a way of reaching new audiences?
Probably the most appropriately developed materials would have been in the MicroMuse Pueblo project, because that was funded and it was done in a public school. So if you do a search for either Pueblo, maybe even MicroMuse, although that's not its name anymore, you might find some materials on their website. I don't know if the teachers at the school in Worcester had any material, but we kind of coached them along. We were only 3 teachers, so we didn't generate anything like that. And also, our project was never funded. So things like that tend to take a fair amount of, somebody has to pay to do it. So most of the materials that are available for MicroMuse are not developed like that. They were developed by the participants, for the participants, without regarding whether you were a teacher or a student or an adult or parent, whatever. So materials are not designed specifically to target teachers on our system, although you might find some there. What you will find are some articles that were written, just explaining the whole thing. You'll find some on the website, and you find some similar articles on the public website that were written either by the project managers, the faculty, or by the teachers. And even you find some articles written by some of the students who
I've heard there's some places on the web where you can explore certain ancient worlds. I'm not sure exactly which ones have been out there, but I gather it's a graphical kind of a thing rather than a text-based thing. But I see with the text-based thing, one of the attractions to these educators is the kids get to, or anybody can, create their own places or things or whatever. What is doing now what it did back then?
You mean in terms of graphical stuff?
Well, no, in terms of a place where people can play around and create extensions to worlds and things like that.
The only new thing I know of that I know of that's worth looking into, and it's not in mud, is a system called Squeak. And it's developed by a very famous researcher in educational technology. His name is Alan Kay. He was at Apple, he was a Disney fellow, he was also at Xerox PARC in the early days. He's now semi-retired, and he's developed a system called Squeak, which is a really powerful system. It's graphical, music, does everything, internet. It's not a synthetic world like a MUD is. You can build, like you can build a car that you can drive, okay? Graphical stuff. And so if you're interested in educational technology, that's up and coming, state of the art, and pushing the envelope, do a search for, I think it's just www.squeak.org. And I saw a demo recently at MIT, and I downloaded it, and it runs on everything. It runs on Macs, it runs on Windows, it runs on Linux, it runs on XP, it runs on a Palm Pilot, I think. It runs on everything, and it's written in a language called Smalltalk, which is an object-oriented language. And they've been developing it for like 20 years.
Is that a multi-user kind of thing, or is it a play on your own computer kind of thing?
It has an internet feature where if you know the IP address of somebody else, you can make a connection, and you can even give them a little copy of your window, and you can even give them control. So somebody can show you how to do something. You can let them essentially have a copy of your mouse and a copy of your window, so that you're sharing. It's like sharing a blackboard. It's not a MUD, but it's a collaborative. It's a system that supports collaboration. And so those of you who are looking at new technology, forward-looking technology, I would suggest you look into Squeak and see if it's something you're interested in.
Do players talk to each other on screen?
Yeah, they have a chat window, typing conversation. Yeah.
MicroMuse, it sounds like it's been effective with kids from different or income kids or maybe, how come the schools have been jumped on this? I mean, it sounds like this is something that the kids love and it sounds really effective. How come?
It might be marketing. That is, that this has been marketed aggressively. It might have caught on. But you have to understand that when we started MicroMuse, I had no intention of competing with the public schools. I had a different philosophy than the public school education philosophy. And I wanted to go off in a direction that did not at all interfere, was orthogonal to the public schools. So when a few public schools used it, I thought, at first I didn't think it would work at all. I was really astonished. I mean, we had a lot of homeschooling kids on, and I was pretty confident it worked for them. And we had kids who were going to public school, but they were bored in tears. And this was a hobby for them, and they loved it. They were learning all kinds of great things. When they started using this in the inner city schools, I frankly was skeptical that it would work. And nobody was more astonished than I was at how successful it was. But it was only done in a couple of pilot projects in 2 or 3 schools. And for some reason or another, it never caught on.
I'll talk very briefly about the MicroMuse project. The first year they did it in the public school, they did it with a small core group of teachers. This was a large inner-city public school, Longwood School in Phoenix. There were a few teachers who had participated in the summer camp, who loved the idea, who were interested in giving this a shot, who got their kids involved. Lots and lots of wonderful anecdotal evidence that this was really helping some kids a lot. Kids who would never have opened the book were running to the dictionary to look up a word because they were speaking online with an aerospace technician and they didn't want to misspell the word airplane. And the librarian came and spoke at a conference. And this kid who had never been in the library was asking her for a dictionary. This was amazing. This was great. What were the problems with it? Other anecdotal evidence, there were kids who begged their parents not to move again this year, please, because in another school I won't have access to Pueblo, or MicroMuse, whichever one they were on that year. A couple of problems. One is, the following year, the school tried to do it with every class. And by trying to do it with every class, sort of mandated down from the top, they hit a lot of resistance with teachers who already had a curriculum. This was a new thing they suddenly had to learn. Those of you who are teachers and who are struggling already just to learn your brand new science curriculum, do you also suddenly want to have to learn a brand new programming language well enough so that you can teach it to the kids? The teachers who signed on the first year were really comfortable not knowing everything. In fact, one of the best things about the project, from the point of view of the kids, is that the kids knew as much as the teachers, sometimes more, and could teach the teachers as they went along. We heard in the second year of the project, we heard sort of more negative anecdotal stories along the lines of, instead of just letting the kids learn to build, the teachers were pre-programming activities. Build a drawer, okay, put in socks. And that wasn't the point. The point was to let the kids figure out what to do. The other problem is, the big problem, Longwood dropped it for two reasons. One was test scores didn't go up. Attendance went up. Dropout rates, to the extent that you could measure them, and to the extent that kids in 6th grade drop out, that is to say by being transferred, did go down ever so slightly, although for the most part, parents who were going to move were going to move in the migrant community. The big thing that went up was attendance. The big thing that did not go up was test scores. And as a result, the department, the Maricopa County, withdrew its support. There were also political problems. The principal, who was the main guiding force behind it, ended up being embroiled in some sort of a scandal where she didn't immediately report abuse and ended up being fired and sent to jail. And the person who came back in was not nearly as interested in this project as her. So there were a lot of problems from a lot of different levels. Why didn't it also get picked up by a lot of other schools? I think Barry answered that. There wasn't a big corporation behind this. This was being grant funded on a one school at a time basis in one or two schools.
Just how then do you, as people really involved in this, how do you measure the effectiveness of it? Because I would assume that if I had something like that in my class, that was helping the kids get more engrossed in what he was doing, then obviously it follows that they should just become small things, really.
This gets right to the thing that I didn't give the talk on, and that was, there's a theory that underlies my research. I've been working for about 16 or 17 years on the theory of emotions and learning. Theory of emotions and learning, which I think if I have time or sometime maybe your class, give a chance to hear about this theory. And I wanted to test the theory. And I had two venues for testing the theory. One was the Science Museum, where we sat and one was MicroMuse. So what was driving me was not a desire to transform education, although I felt that was something that needed to be done. I was going to be the person who's going to come along single-handedly and change education in the United States. But what I did want to do was to see if I was on the right track with this theory of emotions and learning. I needed a venue where I had the freedom to create a learning environment that could test the theory, which meant I couldn't do it in public school without, essentially throwing out the existing curriculum and changing the whole philosophy, because this theory kind of turns everything upside down. So I needed an environment where the kids were coming voluntarily, not coerced, not because the law says you have to show up, not because there's any curriculum that says you have to learn this, that, the other thing. Because I wanted to study the relationship of emotions to learning, where the learner was in charge of the learning. The learner was choosing what they learned. So the thing that David talked about with the problems, the control issues, who's in control, we didn't have that situation because in MicroMuse, the theory was every day, everybody's ready to learn something. What are you ready to learn right now? Let's learn that. So I didn't have, except for the fact that I was sort of pushing science, because that's really what I thought was fun, what I was sort of best able to do. Really, it was, let's create an environment where the kids can learn what they are ready to learn, interested in learning, want to learn, and can have fun learning.
Which unfortunately does not always fit into a school curriculum.
Right. On the other hand, we had kids who were very, we had kids who come in, and they would love to learn, but in school, they were reporting boredom, frustration, and anxiety as the dominant emotional climate day after day, week after week. So if you're in a climate where the emotional rewards are boredom, anxiety, and frustration, you know, who wants to go to that theme park? But if you can go to a theme park where curiosity and fascination and intrigue and, you know, being engaged in challenging puzzles and, you know, and emotionally satisfying construction, all this kind of stuff. So we wanted to do one where the emotional climate, emotional rewards for learning were the ones you want to have. Well, who would want to know that, especially if it's free, right? So the kids were coming in, they would discover this, and they were having a ball, and they were learning like crazy. They were learning all kinds of stuff. I mean, they were learning language skills, because you had to use language to communicate, but they were learning object-oriented programming, which most adults don't even, you know, in public schools don't even know what that was. Okay. And they were learning, you know, leadership skills, communication. So we had kids come through and make enormous breakthroughs. You know, every kid would get to some point in life where they were sort of stuck. And then we'd try to figure out where that is and create an opportunity for them to break out of whatever box they were stuck in, and they'd have these breakthroughs. And then, you know, it's like watching the Olympics. You see somebody having, you know, mastery and success, and self-esteem goes up, and their energy level goes up, and you know, wonderful things happen. So the idea was we weren't trying to teach a subject. We were trying to examine the relationship of emotions to learning and create an environment where good things could happen, and sort of I want to prove the theory.
And I think it is unfortunate that the way school departments want to measure this, which is specific kinds of tests, would actually have shown an improvement if this project had been allowed to continue for long enough and with enough kids. But there was a limit to the amount of time before the project was make or break.
And a Montessori school system seems to be ideal for it because they don't have the graded structure. They don't care. It's really the kid is, you know, at this point, everything at any one particular time. Have you tried it?
Yeah,
Have you tried to market this thing?
well, in fact, the Discovery Center where I'm a volunteer in Assessment is a Montessori room. It was designed by a person trained in Montessori. And so instead of going to a Montessori school, just every Saturday go to the Discovery Center, and it is a Montessori room, and we have different people coming in, the public coming in. And so I have certain activities that I do which demonstrate and develop the art. So for example, one thing I do is I put out puzzles. I have this bag of puzzles. I see the puzzles on the puzzle counter, and people come in and they pick up the puzzles. And over the years, I've sort of figured out what puzzles are the right level of difficulty for casual visitors to the Science Museum. And we set it up so that you pick up a puzzle, you're intrigued, you're fascinated, but you're challenged. You wrestle with it a little bit. You might experience some frustration because it's hard. Okay? But with the right environment, the right kind of coaching, and maybe some judicious hints, but not giving it away, they solve the puzzle and get a bit of euphoria, a bit of endorphin when you solve the puzzle. So I can sort of shepherd people around this emotion cycle: fascination, curiosity, puzzlement, confusion, bewilderment, frustration, maybe even despair. I'll never get this. Okay. And then they do get it, and then they have the emotional high at the end. And I combine that with some other coaching techniques, and I found that I can teach a 7-year-old kid to solve a very hard puzzle known as the Tower of Hanoi. Somebody saw it last year. Tower of Hanoi is a puzzle where the method of reasoning to solve it is so advanced that most people don't learn it until they're in graduate school in computer science. And yet, I find that reliably a 7-year-old can master this in about 20 minutes with appropriate coaching. And so part of it is the coaching. So yes, I do this sometimes in the Muse, but actually nowadays more in the Discovery Center face-to-face. Mainly because I'm at the point now where I have to read people's facial expressions and body language in order to cue myself as to where they are emotionally. And in the Muse, people have to learn to reveal their emotions. You have to develop the language of expressing emotions in music, which is all by itself, that's a good thing to do. But up to a point, people can reveal their emotions voluntarily, and then at some point you have to have face-to-face contact and read the nonverbals. And so right now, I'm doing that more face-to-face in the Discovery Center, sort of the next layer down the process.
Wanda, what are the next steps that you are planning with the news or this?
I'm not planning anything particular with the Muse. We do have some next steps in my research program that goes beyond the Muse. And so the theory of emotions and learning has now reached the attention of the National Science Foundation. They gave us some funding at MIT to do some work on that. And so now the theory that I tested originally in the Muse and the Science Museum is now finding its way into the legitimate research community, and I've been presenting some of these things. And the next thing are the next layers of the model. So I've got the theory of emotions learning model and a couple of other connected models, which I'd love to tell you about someday. It's another 30, 40-minute talk. So we are evolving these models of how learning works. And someday, this may change the way people design educational systems.
I'm thinking two different thoughts at the same time. First is what if your theory is wrong?
I'm sorry?
And so what if your theory is correct, okay, and, where learners should essentially go in their interests lie. My first thought is, it's like educational anarchy.
Yeah.
It's like, what does the educational community, put that way, do with that theory? That's the first thought. The second thought is, obviously we know that a lot of focus on schools is socialization, getting people used to being there on time. It's 80% of success now is just showing up. And a lot of what school does is making people just show up. And I have a child in first grade right now, and he's a boy, and he's actually slightly autistic, so school is more challenging for him than for the average child. The point I'm making is that I see it every day that those are hard lessons to learn. Do what the teacher tells you to do. Just show
It's
up.
all about obedience, isn't it? School is about inculcating people into the culture of obedience to authority.
Yeah.
You lack the machinery to do this stuff. And so you get people who are very obedient, and very uncreative, and very dull, and very unhappy, and very oppressed. Okay? And maybe very autistic. Okay?
Got that in wrong.
Okay. By the way, if you look at autism, there's one particular variety of autism you may have heard of called Asperger's syndrome. That's what I am. I'm borderline Asperger's. Now, I actually didn't know that until a few years ago when I met a kid, a 13-year-old kid who was diagnosed as Asperger's. And this kid was a 13-year-old kid in middle school, and I walked into the computer lab, and he was on the web studying subway maps. Washington Metro, the Paris Metro, the New York City. He was studying all these subway maps, and also the analysis to when a route needed more buses and less buses. I said, he is doing operations research. He's doing graph theory. And he showed me what he was doing. And the reason I recognize this is because I did my PhD in operations research in graph theory. That's why I recognize it. This kid is doing, all by himself, stuff that I wrestled with in graduate school to get my PhD. And turned out he was interested in game theory. He was interested in the same stuff I was interested in, except he was doing it 10 years before I became involved. But the other thing that was interesting about this kid is he was more like me than I am. And what I mean by that is that if here's the average population, and here's me, here's him. He's in the same direction, but like twice as far. And he was diagnosed, so I thought, if he's Asperger's, then I must be borderline Asperger's. And one of the things about Asperger's is you have high mathological intelligence, very good at math and logic. He was terrific at all that stuff. Pretty good language skills, but the deficit is emotional intelligence. Can't read body language, can't figure out, where somebody is emotionally, can't read the thing. And that's where I was. I couldn't read body language either. Still can't read it very well, although I'm learning how. That's why I like now rather go to the science museum and watch kids, because when kids are working puzzles, usually when you talk to somebody, you watch their eyes glaze over, you're bored, right? If their eyes kind of widen, then you're interested in what they're leaning for. Well, when kids work puzzles, it's not in their eyes, it's in the mouth. Oh, the mouth just goes nuts when they're working puzzles. It's really, and so you're watching kids work puzzles, and you want to know when are they to the point where they're about, stumped, ready to give up. You watch the mouth. So I'm learning to read, now I'm learning to read facial expressions better than most people, because it's now part of my research. So there is hope for Asperger's.
I mean, is your point really the traditional, do you really believe that, you're very correct, that the educational system is going to need to kind of grow out of the curriculum?
It has to evolve to something. Here's the point. There is a natural mechanism by which learning occurs in the human brain. Okay? To the extent that we understand how learning works, we can create an environment which is matched to it, what I call an optimal learning environment. Okay? The public school system, as it was designed 150 years ago, is far from optimal. Okay? Montessori's pretty close. It's not exactly this, but the idea is, what is an optimal learning environment that's designed to foster learning and the pleasure of learning, the joy of learning, and the payoff of learning? And how can we demonstrate that? How can we build it? How can we demonstrate it? How can we evaluate it? How can we come to believe it? Because you have to stop believing in the old paradigm and start believing, get some confidence in the new paradigm. So one thing I will invite you all to do, every Saturday afternoon from about noon, or about 12:30 to closing, which is about 4:30, I'm in the Discovery Center at the Boston Museum of Science. If you're a skeptic, or even if you're not a skeptic, come and visit me any Saturday afternoon and observe the process. Okay? This is a model of an alternative learning environment. People are coming voluntarily. They're paying money to come voluntarily. And there I am stumping them with these puzzles. And they're loving every minute of it. And just, explore some alternatives.
I think we have to say thank you to Barry. Class coming in here in a few minutes, but I have the computer lab reserved.